The problem tells us that all 6 machines work at the same rate, and it takes 4 machines, or 4 machines can finish the job in 27 hours. So let's let X be how long it takes one machine to work. So if it takes him X hours, his rate is a reciprocal of that, would equal 1 over X. We're talking about one machine. So if it takes one machine X hours to do the job, his rate is 1 over X. So if I have 4 machines, then that rate would be 4 times 1 over X, which is 4 over X. And we know that rate times time equals work, or getting the job done. So if you have 4 machines, that's 4 over X times, they say it took 27 hours. That would give me the work. So just leave that as 4 times 27 over X equals work. So if you have 6 machines, that would be 6 over X times however long it takes them, and that would give you work. And you know this has to equal this, because the job, it's the same job, just one is with 6 machines and one is with 4 machines. So 6 over X, 6 machines, times time equals work, and that must equal work, and the other work is 4 times 27 over X. So let's solve for T. If I solve for T, it's how long it takes 6 machines to do the job. Well, let's multiply both sides by X first. And if you multiply both sides by X, those X's cancel. I'm running out of room. And that leaves me 6T on the left equals 4 times 27. So that's time equals 4 times 27 divided by 6. 2 we're going to 4 twice. 2 we're going to 6 3 times. 3 we're going to 3 1 time. 3 we're going to 27 9 times. So 9 times 2 is 18. So it takes 18 hours for all 6 machines. Took 27 hours for 4 machines. So 27 minus 18 is 9. So 9 fewer hours. That's your answer.